Welcome to an episode of Compose with Jon Gjengset, otherwise known in my botched Norwegian as Jon Gjengset, on reliable software. That is, what are the tools, techniques, and methodologies for reliably building reliable software? Compose is an interview podcast for software developers using the Rust programming language to build a better planet. My name's timClicks, and I am your host. The podcast is also self-sponsored. If you would like to support the show, you could either do so directly by subscribing to my Patreon at patreon.com/timclicks, or you could ask your company to engage my consultancy, accelerant.dev. Accelerant provides training and consulting to companies worldwide, and it would be wonderful to be able to help you get better with Rust. Visit accelerant.dev to learn more. Enough from me, though. Let's hear from Jon.
I've been summoned.
Yeah, right. I want your thoughts on the question of, how do I write software well? Not just the code, but everything around the build and everything that goes into it to ensure, or at least reduce the likelihood of essentially shipping a broken build or minimizing the possibility of bugs, however you like to phrase it, essentially creating robust, reliable software. And you, I don't know if you realize this, are one of the best people in the world at this.
I smile because it's disturbing to me if it's true. But it is something I spend a lot of time thinking about. So maybe it is. I genuinely don't know, but I sort of hope it isn't, right? I hope there are people who are thinking more about this and are smarter at this than I am. But I certainly have experienced my set of pain with this area.
Yeah, so kind of to elaborate on that maybe as a bit of a segue, which is going to make this very hard to stay on time for, that there's two things that come to mind with that response. One is that writing software under time pressure, or under essentially the weight of organizational bullshit, is really hard. It's very difficult to lobby for extra engineering resource to fix bugs, to get the CI system working correctly, or to there's a flaky test that we can't figure out why it's kind of randomly doesn't work sometimes. And these are not areas where most people essentially spend their day. They kind of want to get a, this is almost the worst place
they have
for
something to get done.
Right. They literally need to get the story, they got to close tickets, right?
Yep. They got to ship
eventually. And, the other side is that I sort of have come to realize, as people have called me an expert in things that I feel uncomfortable about because I'm very aware of everything that I don't know, that very few people like to say that they're an expert. And especially this kind of fluffy or very privileged, one of the world's best and those kinds of tributes.
Well, I think this is sort of well-known, I don't want to say trope, but a well-known phenomena, right? Which is the more you know about a field, the more you know that you know nothing, right? and this has certainly been my experience too, is that the more I learn about sort of how to craft software well, the more I realize that this is an endlessly deep pit. This is truly an abyss where the more you stare, the more you discover all of the horrendous truths about how we build software and how it's not good enough ever. And so this sort of gets at the, I think I wouldn't call myself an expert in it because I know there's so much to know, right?
Mm-hmm. Yeah. And the other thing, and it just comes to mind, is that essentially everyone is faking it, or at least that's how it comes across. That more places that I've kind of dug around behind the curtains, it's like everything is on fire.
Yep.
And the bigger you get, the bigger the fires get. But
no, you're totally right. You're totally right. And it's interesting actually, because to me, there's sort of, if there was one message I wanted to convey in my Rust Nation talk, it wasn't any particular technique, right? It is more of a mindset of you can always do better. Like genuinely, like everything you're doing to make your software, high quality or well assured or however you want to frame it is insufficient. It's all insufficient, but you can always do better. And the question to ask yourself is, what is the point of the trade-off curve between cost and reward that you want to hit? Because you can spend truly an infinite amount of resources on making the thing you ship high quality. But if you don't have infinite resources, so if you choose to spend all of your resources on making it, high quality, that also means it is not changing. You're delivering no features, you're shipping nothing new. You will endlessly churn on sort of quality improvements that are not, delivering what your users ultimately need, and your business fails. So like there's some point in the spectrum where you say, we've invested enough in improving quality now, and we need to now ship things. But where you lie on that trade-off boundary is going to vary from company to company, from person to person, from product to product.
Yeah. So you're essentially framing this as an economic question, right? We have finite resources, and we need to kind of distribute them somewhat efficiently.
I think it's not just economic, though. I think it goes on. It goes into let's call it human perseverance as well. Like if I got tasked with spending 100% of my time on improving the process and writing tests, then I would leave, right? Like that's not what I want to spend all my time on. And so as a company, it's not just, the monetary or economic cost. It is also, you need to balance the sort of creative engagement of the people who work on the code. Because developers have I think a need for variety in their work. And so
I think people have this desire for kind of novelty, or at least it's actually really boring to figure out like why that broken test or that flaky test is actually breaking. It sucks.
Yep. And at the same
nobody cares.
And this is something I experienced at Amazon. It's something I experienced in my current job. It's something I've experienced in the sort of open source world, that I'm pretty good at digging into like why something doesn't work. I can put like my microscope, the goggles on, and zoom infinitely deep into why does this test flake? And it ultimately ends up being like, it's this kernel configuration parameter that interacts with this firewall rule and this version of Rust. Like something truly like at the intersection of a bajillion things. And it can be very satisfying to discover the underlying truth. And I think sometimes you learn a lot about how your software works, how your operating environment works. But I wouldn't want to do that all of the time. Sometimes I want to build a cool feature, right? Sometimes I want to write some software from scratch. Sometimes I want to like talk to a customer and they tell me, hey, I can't do X. And then the next day I go, you can do X now. Those are exciting conversations too. And I want both. And I think most developers do.
Yeah. So let's talk about the boring stuff. Or at least let's talk about the fact that we, at one end of the spectrum, we could spend infinite resources. But right now, we are probably, let's just assume that we're starting out. We had something that was written in Java or C# or Python or whatever else. And someone came along, last year and said, I think we should maybe like rewrite this component in Rust. And so you started with cargo new, and you kind of have some working code, but let's say that your test suite kind of is quite patchy. It runs really well, but you don't know the limits of that performance. Like how is that scenario for you?
So it's a very specific scenario. And the reason I say it's very specific is because I think if you're doing a porting job, then that brings you down a particular like workflow. It's not any worse or better than the alternative. It's just I think the things that you focus on if you're porting software are different from the things you focus on if you're building software from scratch. So usually when I port software, like you already have a thing that works in language X and you want to turn it into language Y, then there's a very specific 3-step process that I follow. Step 1 is a verbatim rewrite. Like I take the original code and I transliterate it to Rust. I change as little as I can. I leave the same function names, the same variable names, like everything is as close as possible to the original as I can. This is something that is truly painful to do. It's not painful in the sense that it's hard, but it's painful in the sense that you're going to spot so many things you want to change. And you
it's
need to
awfully mechanical.
It's awfully mechanical, but it's also like my taste buds, my like programming taste buds hurt because I'm like, no, this variable shouldn't be called this. So as you do this verbatim rewrite, you leave a bunch of comments to yourself that are like to-dos or, fix me's or whatever you want to label them, like in the code saying, in the future, I want to change this in the following way. And there are 2 reasons I do this sort of verbatim rewrite. One of them is it forces me to read and understand all of the code. All at once, I have to understand the whole thing. And I think there's enormous value to that when you're initially doing a port, because it makes you put everything into the sort of working memory of your brain, and you're going to spot patterns across the code base that both let you understand it better, but also start to see more systemic issues so you can tidy up later that you wouldn't see if you, let's say, tried to implement module by module. The second reason I do it is because usually when you do a rewrite, the old thing does not stand still. That is at least very rare, right? Like usually some team is tasked with a rewrite and then the original code like is still a thing the company ships or uses or whatever. And so it keeps evolving. And what's nice about doing it this way is that you can do a sort of a follow-up process where after you've done the bulk of the work with a verbatim rewrite, then, hopefully you recorded like which commit hash of the original thing you ported. And then you look at the diff from that hash until the head hash of the original code, and then you port just the incremental bits. And so now it's much easier for you to get back up to speed. So that's step 2. Step 1 is the bulk rewrite. Step 2 is the catch up to the original. And then step 3 is now you get to improve. So now that you have the whole thing, now you can start moving things around, changing things to however you think they should have been done in the first place, optimizing all of the bits. And there's sort of an overarching, what should we call it? An overarching step, maybe, which you do throughout, which is try to convince yourself that the thing that you are building is equivalent to the original. So the ideal case of this is that you do input-output testing. So for any given input, your program and the original program produce exactly the same output. That's not always feasible, but where it is hugely valuable. This could even be things like you run a fuss tester. The fuss tester generates inputs for both, and the output from both should be the same for every fussing input. So you can think of this as you have a perfect oracle, right? The oracle for your fuss tester tells you, what should the output be, and the original code is the oracle. Sometimes you discover that your implementation and the original differ, and it's actually because the original was wrong. But that is still a helpful thing to come out of the process.
May I pause you there?
Yeah, go.
I'll just play moderator and check that everyone knows what fuzz testing is. Do you want
Yeah,
to?
okay. I'll do fuss testing real quick. So fuss testing, or the more advanced form of it known as property testing, is essentially that you generate random inputs. And in sort of very classical fuss testing, you generate random inputs, you give them to your program, and you see if it crashes. If it crashes, then you hit a bug, right? Like a program should never crash. It should maybe exit with an error code, that's okay, but it should never crash. And so fuss testing often sort of started with cryptographical libraries or sort of parsers and the like, or web libraries. You just throw a bunch of random bits at it as inputs, like random strings, and you see that it never crashes. It always gracefully exits. And then the evolution of this, and this is often what's known as property testing, although there are variants of fuss testing to do the same thing, is that you're not just checking that the program doesn't crash, you're also checking that it upholds some property, right? So you can do this through assertions in your code, which cause the thing to crash, right, if some invariant is not upheld. But you can also do it by checking some property of the output, such as, a trivial example of this would be if you're doing property testing of, let's say you're implemented your own map
Crypto.
type. Like,
No.
well, hopefully not crypto, but let's say you implemented your own map type, like a hash map.
So yeah, we're associating between keys and values.
Yes, exactly right. Dictionary in good old the Python speak. Then the way you could do property testing is that you take some implementation of a map that you know to be correct, either because it's very well tested, like the one from the standard library, or because you've written it yourself and it's stupid simple. Like it just keeps a vector of key values and just looks through it in linear time. So it's super slow, but you know it's correct. You can very easily convince yourself it's correct. And then what you do is you fuss a bunch of inputs, where the inputs are maybe keys or values, or maybe they're operations over the hash map. You apply all of the inputs to both the known good version and your version, and you see that they end up with the same final state, the same final map. And this is what would be known as property testing. You're checking that the outputs correspond in some way. And the correct thing is usually then called the oracle, because it's the thing that knows the future. It knows what correct is. And so now we need to, I was going to say, now we need to pop off fuzz testing and property testing from the stack.
And get back to your third point, or your third step of, like, now we get to improve. So you're essentially creating a foundation where you can verify that the new code performs identically for the identical output. Essentially, it is, if it were a black box, we could swap one out for the other.
Exactly right.
And right. Okay.
And so the idea here is that you do sort of a fuss testing or property testing where the oracle is the original implementation, and you're testing your new implementation. You're seeing that for every input, they produce the same output. And you can do this both at the sort of wholesale level of inputs to the program as a whole and outputs of the program. You can also do it on sort of a lower level, such as, imagine that the original code was written in Java, or let's do Java. Java might be a good example here. Then what you could do is you could use JNI to be able to call Java functions directly from Rust. And then you could property test individual Java functions in the original implementation and property test them against your Rust implementation of that same function. And remember, because you're doing a verbatim rewrite in sort of step one, you know that you have a Rust function that is supposed to be the equivalent to every Java function. If you don't, then that means you didn't follow my rules about doing the verbatim rewrite in step one, right? And so if you do this, you can property test the whole thing and also all of the sort of complex intermediate parts. And hopefully by the end, you should be fairly convinced that your Rust rewrite is accurate. And at that point, you can start to rewrite. You can start to, move code around, optimize, change the structure, make it more idiomatic, make it generic, whatever you might want to do. And hopefully that test suite should continue to uphold the fact that your code is equivalent to the original code. And then the interesting thing becomes when you want to diverge from that. If you, decide that I want to add a new feature, you no longer have an oracle, and now you need to do all these sort of other testing properties. But that's later. That's after the port is.
What I just commit myself to absolutely geek out on this topic because I love fuzz testing, and the real interesting thing about the way that they're implemented and how they search. So it's not just, it essentially starts as random input, but really good fuzzers actually have search strategies and for being able to find really pernicious input, which is likely to trigger bugs. And it's fascinating, this idea that you can essentially have millions and potentially billions of permutations of inputs. And if you're exposed to the internet and you're a high profile service, that kind of rigor is really quite important. And, so that was just me allowing myself to say thank you to everyone who works essentially on this invisible side of the software industry, that essentially helps other people, this kind of tooling side of, or software for software developers.
No, it's true. I wanted to, there's sort of a related bit here to what you just said, which is some fuzzers are pretty smart about how they explore the program. The extreme version of this is something called concolic execution. And we can decide how deep we go down this. I'll describe it at a high level, and then you can decide whether you want to do this rabbit hole as well. So concolic execution is a variant of symbolic execution. An example of something that implements this in Rust is Connie. And the idea here is that you, let's say that you have, some function you want to call, and it takes one argument, of, let's say, type string. Then what you would do in a fuzzer is you would just tell the fuzzer to generate random strings. You would call the function over and over and over again, and Bob's your uncle, as they say. But with Connie, what you do is you ask Connie for a string. You pass in the argument like Connie : any. And what that will do is it will generate some string, like some random string, and then it will run your program. But it'll run your program in a special mode where it's actually being interpreted kind of like Miri rather than being, compiled and run as native machine code. And what it does is as it executes, it keeps track of every comparison that is ever made in any part of the code with that variable. So if you ever do a check on like the length of the string and you have an if based on that, or you do a search, or you search a particular character, whatever comparisons, whatever conditionals you have that involve that input that Connie originally gave you, Connie will track. And so let's say, maybe a number is a more easy to follow example. So Connie gave you a random number to begin with, and as part of executing this function, the function will compare the number to 0, and it will compare the number to like some number over 9,000, right? Then Connie will see those two comparisons. It will see that the current number it gave you was not equal to 0, and it will see that the current number it gave you was less than 9,000. And so it knows that those are the current paths through your program. When the program finishes, Connie will then take the conditionals that it saw that you walked through, and it will hand it to an SMT solver, which is basically a fancy way of saying like an equation solver. And it will say, give me a value for x such that either x is equal to 0, because previously it was not, or such as the value is less, such as the value is more than 9,000. So it's basically trying to flip the conditional for one of the conditionals that it saw, and the SMT solver will come back and say, okay, try x equals 9,001. And then Connie will run your program again, but this time when it calls Connie any, it will give it 9,001 instead of whatever number it gave it before. And then it does the same thing. And so that way, rather than randomly searching the input space, which for numbers is pretty large, you specifically search for only the values that trigger particular paths through the conditionals of the code to give you effectively what's known as path coverage. And so this is essentially a very intelligent way to search through your code base. It is slower because, you need to now interpret instead of compile and run and whatnot, but it is a very good way to explore this kind of fuzz testing in a more intelligent way.
slower is, I almost feel like it might even be the wrong word, just because it's much faster than fuzz testing.
Yes.
So these model checking approaches have this property whereby they don't need to essentially brute force the search space. They can kind of essentially track exactly where the program is going and find their way essentially around the corners of like all of the conditionals and so forth, just as you've been describing, and can kind of zone in or sort of target difficult areas. And it's actually, so I am more than happy to discuss model checking. And the only thing is that I wonder if we've jumped ahead, because because one of the things that I'm wary of is there will be people, and the reason why I sort of originally created this porting scenario was just because I was trying to think of like, well, let's think about the kind of people that are going to be listening to a Rust podcast and be trying to improve their code. Well, they might have started with some project and they might not have quite known what was idiomatic yet. They might not, because they might have been Python developers. They might have been whatever developers. And so there was this promise of Rust. And so they thought they would try something out. It could have been Greenfields, but it might have been porting. I really like this 3-step process. And I'm going to see, I want to check if if you have a similar model for how you recommend people develop Greenfields projects. But the next question after establishing the scenario was going to be, where do we start with essentially shoring up the software? Like we've developed a proof of concept, and now we essentially want to give it strength, or we want to, quote, productionize the thing. However, thank you very much for taking us on this journey, because it's utterly fascinating.
And
really
I
important.
mean, I'll say that this is an example of what I alluded to earlier, that this is infinitely deep in every direction, right? And so you could build high quality software and do none of what we just talked about, right? But that is then another thing you could do that is painful. Well, what I'll do is to sort of to end us from this part of the conversation is, if you're curious about this kind of concolic execution and SMT solvers and whatnot, there's a class at MIT on computer security that actually has a lab that comes with the lab instructions and an auto grader, and all of the code and all of the stuff is available for free. So I'll send you the link, and it goes through doing sort of concolic execution, basically implementing part of it yourself in Python. And so this might be a good thing if you just want to understand this topic more broadly and like the mental model for it. It's a really good read. So to use that to sort of say, we can stop talking about this now because they can learn more on their own, and then take a step back to.
Yeah, at least what we don't want to do is scare people away.
Yes.
And say, like I literally do not care. Or it's like, well, I don't want people to say I don't care, but I don't want people to feel like they need graduate level education before they can do anything meaningful to start. In practice, fuzz testing, property-based testing, and model checking, or kind of these suites of tools are actually much more accessible than they look on the outside, I would say.
And this is actually why I recommend this class, because it's not a very hard lab. It is just a very good way to learn this with like hands-on experience. It's not even, I think it's an undergrad level class. So like it's a very good introduction to this topic where you get to sort of get your hands dirty in it a little bit. I think also, my experience when I tell people about the sort of model checking approach and fuzzing more broadly is actually more one of excitement, that it's like, oh, that's so cool. This seems like a great way to test my stuff, because now I don't need to write a million unit tests, because I can just write a thing that essentially does unit testing for me. And then they go to try it themselves and discover that, oh, but now I need to learn a bunch of other things that I hadn't thought about. And so this is, I think, it's not a reason to be scared or to run away. It's an exciting technique to know about and something that might help you in your work, but it's not a requirement. And this was another point from my talk, was that none of these things are requirements. And in fact, you almost certainly will not do all of these. All of the things we talk about here, all the things I talked about in my talk, if you try to do all of them, you don't have the time, you don't have the resources. You have to pick and choose which ones are most valuable for your use cases. And so that's all to say, if you think that these techniques might be useful to you, then look into them. It's worthwhile to at least know about them to make an informed decision about whether they're appropriate for your use case or your use of time or not.
Wonderful. Now, we should segue, or we should return
Greenfield.
Yeah. Actually, let's do Greenfield, because it is the natural next thing. It's this is the wonderful process. Tell me a Greenfield process.
So, Greenfield, perhaps unsurprisingly, I have strong opinions on this too. I'm not going to claim that they're correct, but I'm going to claim that I think they work pretty well. And for Greenfield stuff, there are a lot of proponents of test-driven development or behavior-driven development and the like. I don't love those labels because I think you need to look at what you're building, and what approach you take differs depending on what you're trying to build. And sort of being dogmatic about it, I don't think it's pragmatic. The way I tend to approach writing software from scratch is I start from, how do I want it to feel? So if it is a library, I usually try to write some code that would use the library first, right? So I write essentially what one of the example programs will look like, because it forces me to think about how the API should sort of string together before I've written any of it, before I've thought about any of the complexities internal to it. It's what is it's almost like a sort of clean room approach of, I don't know any of the complexities of the implementation. I just know what it should be like to use it.
I've heard this referred to.
Yeah, go ahead.
I was going to say, I've heard this referred to as README-driven development.
I often write the README first. That seems sort of similarly inclined. And if it's a binary, I think it's the same thing, right? I think about what do I want the sort of high level commands to be. I often actually write the clap command thing first, and sort of enumerate what are the subcommands, what are the flags. It's going to be augmented over time, but I want a rough sort of overview for what this tool should feel like before I start writing all of the innards. And so for me, that is step one of Greenfield is, what is the interface to this thing? What should it feel like? And then go ahead.
I was going to say, before we get to step two, do you have an opinion on exposing, as I don't even know if there is a possibility of having any principled thoughts here, but exposing traits versus concrete types for behavior? Do you kind of have a preference if you could think about it? I don't even know if that's a real question.
Yeah, it's a real question. So the general trade-off with traits is whether you want the set of implementing types to be open or closed. And that's sort of a slightly academic speak for, if you have an open set of types, that means that whoever is using your tool can bring their own type and have it work with your library. If you have a closed set, it means that your library, or your crates, but realistically your library, is the only one that can provide implementations of something. And you can have a closed set of types with traits as well. This is what the sealed traits pattern is for. But if you want to have an open set where the callers of your code can supply their own types for, mocking purposes or swapping implementations or whatever you might want, then a trait is appropriate. If the set is closed, then you can either do just have a single concrete type, or you expose an enum. An enum is similarly closed because callers cannot add variants to the enum. Between these, my experience is that traits tend to make an API more painful to use. It's harder to understand. It's harder to grok. There are more things involved, more moving parts.
Associated types and a bunch of other
associated types. You have generics everywhere. You have to start thinking about stuff like whether a trait is object safe, and that it can get pretty painful. Sometimes it is necessary, right? Like if, for example, Surdy did not use any traits, so it was a closed crate, it wouldn't work because the whole point of Surdy is that you can bring your own types and deserialize them, right? So it's sort of forced into this pattern.
To serialize your type, you actually needed to have a PR accepted into the main pseudo library itself.
It would make no sense. It would be completely unreasonable. And Surdy would have to take a dependency on every crate in the world. It just does not work. And so usually I tend to default to concrete types and then make things be traits when I need to open up the set of types that are allowed. And sometimes, like if the only use case you have for that is mocking, for example, then you don't need to make the thing open. You could have your crate provide a mocking type as well. And now, you can have a sealed trait or an enum. And suddenly it's no longer the case that you need to have an open trait for people to think about. So there are ways to avoid the open type thing, even if just what you want to provide is mocking or let's say 2 different implementations rather than, N where user can supply their own.
So at the risk of turning this into a software architecture talk, there is a question, or this becomes even harder when you're building a framework. So if I wanted, so one of the problems that, or at least the struggles that I've seen large things, like such, web frameworks will typically expose like an into response, whereas they'll try to be as permissive as possible and allow the routes to provide something which implements some type, or at least knows how to be converted into something else. Whereas something like a bevy kind of has this philosophy of avoiding traits as much as possible and using concrete traits, and leaning very heavily on proc macros or to derive behavior and try to essentially keep the trait system at bay because this is something that is almost inherently difficult. I don't know if that
it is. I think you get better at it over time, just by sort of observing when do you need to make something generic. And I think need is maybe too strong. Sometimes it is valuable to make something generic, even if it's not technically necessary. But it's not quite a matter of taste. It's a matter of the trade-offs again, right? Of the amount of flexibility you want to give users of your library versus the complexity you're willing to expose in your interface, right? That's what you're trading off. And sometimes you want to turn that dial in the favor of flexibility. Sometimes you want to turn that dial in the favor of you either want to turn it in the direction of flexibility, but at the cost of complexity, or you want to turn it to less flexibility, but also less complexity. And I don't think there's a sort of one true answer. I tend to prefer concrete types rather than traits, unless there's a pretty compelling argument that you need a sort of open typeset. One important caveat here is that impl trait in return position is a concrete type. I have a whole talk on impl trait that may be relevant here, but if you have a function in your library that returns an impl trait, then that is a concrete type, not a generic type. Right. And it can actually be hugely valuable to use impl trait in that case, because it means you're promising less about what you return. If you return a concrete type, you have to always return that same concrete type. So if you have a library function that returns, let's say, a vec of foos, then maybe it would be better if it returned, an impl iterator where the item is foo, so that later on you can move from having this be a vec to having it be a small vec or something.
Yeah, that's actually a very clever thing to add into this, is that, so just to double or just maybe express exactly what Jon has said, that the impl trait in the return position looks to you like it's really dealing with, it looks as though it's like something kind of almost looks like a trait object. It's like something that kind of feels like, we only care about the trait. But from the compiler's point of view, you are returning one specific type that does implement the trait in the function signature. At that point, once you're going through the compilation process, the compiler sees the concrete type. It isn't relying as much on the trait as what essentially the source code sees. And the point that Jon was making around essentially giving yourself some wiggle room or flexibility is that the source code won't change, or at least the function signature won't change if you go ahead and replace a vector from the standard library with some other collection or small vec, for example, because most of the time you're returning a vector with fewer than 6 items or something. Now, we got to this fork in the road, or this diversion, because I interrupted you to talk about concrete types versus traits. And then, so if you can pull your memory back to the next point after that.
Yeah. So this is back to Greenfield development. So step 1 is you figure out how the thing you build should feel, right? So you approach it from the user's perspective of what should this thing do. And then step 2 is now you need to go and understand the problem domain, right? The thing you're actually going to implement in your code, you need to start writing the code. And I think there's sort of an anti-pattern we see in Greenfield development in particular, where people want to fully understand everything about the domain before they go write any code. And it's useful to think about the problem before you write some code, but it's not useful to think thoroughly about the problem before you start writing code. And the distinction here is important because for any non-trivial domain, you can spend basically infinite time thinking about it, and you can maybe arrive at some theoretical optimal thing, but then you run into the Rust standard library or the Rust compiler language doesn't have higher kind of types, and turns out you needed that if you wanted the theoretical optimal implementation. So the reality is, usually I start writing code pretty quickly. I think about it for a little bit, and then I just start mocking out types to sort of fit the API that I came up with in step 1. And I start just filling in. So in step 1, I write a lot of to-dos, right? I create a type that has no fields, and all of the methods on it that I use in my little example code are all just to-dos. And then sort of in step 2, I start just filling those in. I start writing the actual business logic of the underlying thing. And very quickly, you learn more about the problem domain by virtue of having to actually write the code here. I make pretty liberal use of to-do, especially when I'm doing the sort of initial implementation. The same thing goes when porting, actually, that in the verbatim rewrite I do, I often leave a bunch of things as to-do so that I can do it in multiple passes. Yeah, good.
So to do there, can you confirm this is a comment to do? Whereas I tend to use the to do macro quite extensively.
No, I use the to do macro. Okay. I actually use both depending on what the scenario is. So for when porting, I use both. I use the to do macro if there's a subset of the code or some corner case of the code I'm not ready to do the verbatim port of yet. I just put a to do there. And then I use to do comments to indicate things like this type should probably not exist, or this module should be wrapped up into this one, or this thing should be generic, or, whatever things I identify in my mind while doing the porting. In Greenfield development, it's more of the to-do macro in sort of step one of just, I haven't implemented any of the logic yet. So it all needs, like, the compiler requires that some code goes here. So I put it to do. And it's less of sort of the to-do comment.
So just for any listeners who don't know what we're talking about, the to-do macro is essentially the same thing as a panic macro, except it has a nicer message when the program crashes. The other thing that it does is it satisfies the return type of the function. So essentially it masquerades as actual code. But if at runtime you hit to do, the program will crash with a message saying, "Oh, I haven't implemented this yet."
I'll also add a note here that I tend to use 3 different types of to-do comments. So I have to do.
This is the most Jon Gjengset comment I think I've encountered. Like, that's even better than "it's complicated" to me.
Yep. I
good.
have a lot of these. So for me, I think there may be 4, but I'm going to stick to 3. So the 3 are to do, fix me, and XXX. And to me, those 3 mean different things. And let me explain why. XXX is, I need to change this before I push the code. Fix me is, I need to change this before it goes to production. To do is, this should probably change.
Yeah, I think that is a really smart taxonomy. And I'm actually a little bit disappointed. I was hoping there'd be something a little bit more, slightly less conventional. But and obviously there is those XXX comments should be very rare.
Yes. Although they're very common in the beginning. Like, when you're first doing the implementation, you're going to have a bunch of them. Of like, I'm not handling the case where this is more than one element, right? Like, that seems like a thing where you could either do an assert or you could do an XSX, whichever one, but like, clearly this is incomplete, right? And a fix me is more of a, while writing this code, I've realized that there's a corner case that we're not handling here. It's not trivial to implement. This code is still useful. Like, I'll still open an MR and, this is like forwarding the state of the code. But before we ship this to production, this has to be addressed.
Do you have any heuristics about personal heuristics around when you might reach for assertions, or say the assert macro, or debug assertions? Like, is that a distinction that you care about a lot?
I assert whenever I can instead of writing a comment, because comments are very easy to miss. Assertions are much less easy to miss. I also make pretty liberal use of if config debug assertions. So this is a way in which you can write code that will only compile and run basically in test mode. It's not quite in test mode, but it's either if you're running tests or if anything consuming you is running tests will also run under debug assertions. It's the same thing that guards things like bounds checks inside of the language itself. And so what I will sometimes do is, let's say that I have some code where there's a somewhat convoluted invariant that I want to maintain. Like, let's say I'm storing a graph or something, and it should always be the case that there are no cycles in the graph. Let's say that's a property that I need to uphold. Checking for cycles.
So you want a tree, not a graph. Essentially, you want to guarantee that you cannot have cycles in the graph. Okay, great.
Yep. But checking whether a graph is a tree is like, it's non-trivial. You need to walk the graph. It's doable. Like, there are algorithms for it, but like, it's not cheap. And so realistically, it should be the case that my program always upholds this invariant. Like, let's say that is the case. Then what I would want to do is, at some key points in my code, where those are depends on the code, I would want to check this invariant. And it's not really an assertion, right? Maybe it is, but it is a runtime invariant check. And sometimes I will write those and put them behind if config debug assertions. So like in my, run function, or in my, it could be like in some key function on the data type that stores this, this graph, I will just have code that checks for this invariant inside of if config debug assertions, so that whenever someone runs tests, or whenever someone sort of above me in the crate hierarchy runs tests, if that is ever, if there ever is a cycle, you get a hard error and an indicator of where it went wrong. And so I'm very much a fan of those kinds of assertions.
Yeah, and it's just, again, just a very quick remark for anyone who doesn't yet know the distinction between the assert macro and the debug assert macro, is that when you have a release build, the debug macros are essentially erased, and so the debug assert will run under test. And the other thing that I thought was worthwhile mentioning was that the assert family of macros, so this is assert equals or assert underscore EQ, assert, debug assert, these sorts of things, are very good macros to inspect, that is, look into the source code if you're ever curious about how macros are written, because they essentially eliminate the magic of this idea of a macro. All assert is doing is checking, does this expression evaluate to true? And if it does not, panic. That's essentially the whole thing. And when I was learning Rust, being able to sort of peek into the standard library and demystify some of these tools like macros, which to me were quite difficult. Or at least conceptually, I thought, there's this kind of like, that looks like the dark arts of the language or something. It turns out that they're perfectly reasonable bits of code. And yeah. So hopefully that is useful to some of you listening out there.
I think on the use of assert more broadly, I'm a pretty aggressive assert user. I like to assert anything that we believe is true. This is, I think, maybe the second or third most common thing for me to point out in a code review is, can we assert this? Right? Like often there'll be a comment somewhere in the code that says, we know that X, therefore this is fine. And I go, can you assert that we know this? And you know, whether you make it a debug assert or a real assert, depends on the property you want to check. It depends on how poorly things go if it's wrong. Sometimes you actually get a performance boost out of adding asserts because the compiler or the optimizer really can look at the fact that your program would have exited if a condition isn't true, and therefore it can assume that it's true in the following code and optimize it accordingly. Asserts can actually be beneficial.
We could, for example, add an assert that an input is non-negative, so it's a positive number. And now the rest of the analyzer, sort of the optimizer doesn't have to worry about the case of negative numbers. And for example, there are a whole bunch of things that are slightly counterintuitive around giving ostensibly or on the surface, it looks like we're asking the compiler to do more, but it turns out the compilers are actually very, very smart. And asserts are a tool that enables the optimizing system of LLVM and Rust-C actually to be able to say that essentially remove any. We don't need to do checks twice anyway, I will allow you to carry on.
I think I'm mostly done with this part. That I think assertions and debug assertions are very useful, and this sort of ties in the conversation we had earlier about fuzzing, right? So if you do fuzzing or property testing, it generates a bunch of random inputs and it looks at whether your program crashes. Well, one of the ways in which it can crash is if there are assertions that are violated. And so by adding these assertions, you are in a sense also helping yourself write tests by virtue of then running a fuzzer or property test later.
Mm-hmm. Now, where are we? We have Yeah, so we are continuing our Greenfields development. We're developing our proof of concept. We have started to. We've written our README, or we've thought about the thing. We've written our README. We've started using. We started to sort of prototype some types using lots of to do and both comment form and macro form. We're kind of ensuring we have assertions about invariants that are encoding or wrapping essentially the input parameters of our functions, and let's continue to build.
Yeah. So I think where you go from here really depends on what you're building and what you care about, right? So you can get pretty far with just this process. You can say that this is, you can ship code to production with just this process. I think there are a couple of paths you could take next. One of them is sort of the fuzzing route that we talked about. You could set up sort of fuzzing or model checking for your thing. The other that you could set up is sort of going to the benchmarks and profiling kind of area of how do I make sure that my code is actually fast enough? How do I check that it doesn't get slower over time? And coming up with good benchmarks is its own whole area, a whole field of study. But that is also a path you can take. Another path you could take is more along the lines of like correctness checking that is not about tests in and of themselves, but about running tools. You could start here with something like Clippy. Like many people don't think of Clippy as a correctness tool, but it very much is. Like Clippy does sometimes point out, or often points out, stylistic things like, is your code idiomatic? But oftentimes, if your code is not idiomatic, that might hint at a problem. It could either be a performance problem or it could be a correctness problem. Clippy does have a set of lints that are labeled as
Perf, I think.
dangerous or something.
Yeah. There are, and dangerous in the sense that they are liable for false positives, essentially.
No, I don't mean those. So
okay.
Clippy also has a category of lints that are.
No, that's right. Yeah.
That these are code patterns where you're likely to be shooting yourself in the foot. You might not be, but you are likely to, because it's a pattern that is often misused. And so Clippy can point out those to you. And I've definitely had times where it points out this pattern to me and I go read about the lint and I go, oh yeah, I am making that mistake here. Let me change it to the thing it recommends instead. So Clippy can be a very low bar way to improve the code in this way. And it helps with like making your code more idiomatic and ergonomic and whatnot as well. But to me, that is almost a second order property of the tool.
The other thing that is a relatively low bar is by adding, essentially we can be a little bit stricter in terms of annotating the crate with other things, like maybe we require documentation for public items. And are there other annotations that you typically recommend?
So annotations are on crates and in the sense of turning Rust-C lints from allow to warn is sort of the most common case of me using this. I think missing doc comments is a good one. I think missing debug implementations is another one that's good. But other than that, I actually think that the Rust-C defaults are fairly good. There is one that's sort of missing doc examples, but that one I have I'm more reserved about because I really don't like code that has doc examples that are completely trivial. And this is the same thing you risk running into with missing docs as well, right? Is that people just write docs that are completely useless.
It's like door opener. This type opens the door.
Right, exactly right. And so if you have missing docs, there is a chance you run into that. But I think on balance, it's worth having docs on every function, every type. Whereas I don't think that on balance, it's worth having doc examples on every type and every method. So in terms of tools, Clippy is one. You also have Miri is another great one, especially if you're writing unsafe, where you can just run your existing test suite, but with Miri turned on, and it will tell you now about places where you have undefined behavior. And that is magic, right? Like it's truly just magic. You don't have to change your tests at all. You just run it in a different mode, and now it tells you if you got something wrong. Tools like that are very valuable.
Not just magic, but also extremely humbling.
Yes. That's very true. And then I think there's another path, which is sort of chaos testing. And chaos testing exists on multiple different levels. The idea with chaos testing, if I am to put it very crudely, is that you take your program, you run it, and while you're running it, you're like shaking it a bunch, right? So you're making things happen in weird orders. Usually this is related to things like, which threads execute in what order. But it can also be things like, if you have multiple open connections, like HTTP connection or something, which one gets a packet first? Or if you have multiple timers, which timer expires first? Or it can be things like, what happens if one particular future doesn't get to run for a while, but the others do? And so this is what chaos testing means. It's just sort of jumbling up the execution of your program.
Is there a mutex-like type that sometimes kind of self-destructs or essentially pretends that it's poisoned, even though it's not?
I don't know of that. So lock poisoning is a little weird. It's a Rust unique thing that I think there's been some debate about whether it's even all that valuable. I don't know of anything that does this for mutex specifically. But there are a bunch of libraries in this sort of sphere of things. So you have Loom, which does it basically models the underlying memory architecture or memory coherence, technically, of your concurrent data types. So these are the things in the atomic module. So std sync atomic in the standard library, and makes it so that if you try to read a value from memory using atomics, you might, like, Loom basically runs your program multiple times, and each time you read a different concurrently written value. So it basically tries to explore what would have happened if these threads ran in a slightly different order. You have tools like Turmoil, which is a crate that gives you replacements for some of the networking and timer types in Tokyo, and then has packets randomly be dropped or reordered. It has timers expiring. It's like slightly odd times. It makes futures run in sort of randomized order, or like some futures get to run a lot and other futures get to run a lot less. You have tools like Shuttle is another library that is similar to Loom in a way, but it just runs your program your tests lots of times with just randomized schedulers. So there are a bunch of tools like this that are all in the same family.
Right. So it's sort of the opposite of a fair scheduling algorithm. Like, how difficult can we make the program or the scheduling system? And hopefully the program will continue to still be able to kind of move forward.
And there are two things they're trying to test, right? One of them is, with chaos testing, one of them is that your program doesn't just fall apart, right? Like, it just can't make any progress on anything if you have enough chaos. The other thing you try to check is sometimes there are bugs that lie at the intersection of rare events, right? So a bug that only triggers if, like, you have two timers that are both racing and the second one happens first, and it happens at the same time as a connection is being received, right? Like some kind of weird interaction like that, where if you just ran your test once, the likelihood of hitting this is like basically zero. And even if you ran it over and over, like you just ran the same test 1,000 times in a loop, you might still never hit it, because it only happens if there's a lot of contention where tasks might be delayed or timers might be slow. And so that's what these tools are trying to extract, right? Is this kind of corner case behavior that might be hard to reproduce otherwise.
And that's where the audio cuts off.
Let's see how successful we were at being able to restart a few weeks later.
Nice.
This was much more awkward than I expected. I was just scrolling down to exactly the right place.
I think this is a great start. No context.
So
we're all wearing the same clothes.
We're all gonna wear the same clothes. It's gonna be the lighting's all changed. It's like,
yeah.
So it's the opposite of So it is the opposite of a fair scheduling algorithm. Like, how difficult can we make the program or scheduling system? And hopefully somehow we're going to test this thing and try to get the program to continue to function.
In a sense, yeah. So what you're really trying to do is two things. So chaos testing on the one hand is just to make sure your program doesn't fall apart, right? Like if you end up running it through a very unfair scheduling algorithm, you introduce all this chaos into the networking and dropping packets and whatnot. Can it still make progress? It'll achieve the outcomes that you want. The other thing you want to do is not just to see whether the program crawls to a halt or something, but you're also trying to check whether there are bugs that lie at the intersection of rare events. So sometimes a bug triggers if only these two particular timers are racing and the second one happens first and the first one happens at the same time as when a connection is received that also times out. And there's always really weird border conditions that, might trigger a bug in production 2 years from now, but you wouldn't find them by just running the test over and over on your laptop. And so what chaos testing tries to do, and you see this particularly with something like turmoil, is it tries to make all of these unlikely occurrences more likely so that you end up reproducing weird interactions like this, so that the likelihood of hitting those normally very rare scenarios is no longer zero. Right. And this is a better approach to just running them thousands of times in a loop, because it will mess with the system so that the probabilities of those unlikely events are higher.
Now, are there other tools? I mean, you talked about turmoil and Loom, and we've also got Kani, the model checker. This feels like we're getting this growing list of extra stuff. Do you have other things that you draw from?
I mean, there are a bunch of tools here, and chaos testing is one particular subcategory, and sort of model checking, like we talked about with Connie. You have property testing, like with quick check and prop test, and there are other interesting tools too. One I discovered maybe just a year ago is called Cargo Mutants, and Cargo Mutants is this really neat tool where instead of messing with your execution, it messes with your code. So it basically makes the observation that, well, your tests should be testing for all sorts of corner cases in your code. So what if we kept all your tests the same, and then we change the code and we check that at least one of your tests now fails? So it does things like, okay, take your existing code and then replace a greater than or equals with a greater than, and then see that some tests should fail now, because otherwise that means your test coverage is not very good.
Yeah, okay. Yeah, right. So we've changed the code. We know that this should actually be a problem that we want coverage for. Therefore, we expect some test to just
exactly
say,
right. And I think it's a really, really neat approach. It can be a little bit hard to run it on a large code base just because there are so many places in the code that you might want to change. But even so, it's a really neat insight and an interesting tool. But I think, on the whole, what I'm trying to convey here is not so much that you should be using these specific tools. Instead, what I want to get across is that there's this huge space of things that you could do with your code. And that space is not static. It keeps growing. There are new tools that get built. There are old tools that you haven't heard about, but you discover, tools that get repurposed, tools that get better, new techniques that have evolved, new papers that get written that end up, influencing new tools that can be written, improvements to the language that in turn inform better tools. And ultimately, this is a matter of sort of keeping up to date with the space and just knowing what trade-offs you're making, which tools should you be using and which tools are not quite right for you or not right in that trade-off space between the investment in improving quality and the requirement, the real requirement to deliver, functionality to your users.
People would look at Rust as actually a part of that spectrum. Do you agree?
I think that's right. So Rust makes a very particular trade-off when it comes to if you look at the spectrum of almost iteration speed or like the ability to change things very rapidly in fundamental ways.
Don't tell them that Rust is hard.
No, I'm not saying it's hard. I'm not going to say it's hard. I'm going to say that it makes a different set of trade-offs than a language like Python. Right? So Python, for example, tends to favor prototyping speed, the ability to just quickly try something out. And that might be radically different from the way your code was written previously. In Rust, it's pretty painful because it tries to make sure that you're doing it right. But if you're just like rapidly trying to get something out, trying to test an idea, then you don't necessarily care that it's 100% right. You just want a thing that demonstrates the idea, demonstrates the concept, and then you can make it right later. Rust doesn't allow you to make it right later. Rust requires that you make it right first. And making that sort of advanced payment is not always the right call. It depends on what stage your users are in, what stage your company is in, and what you're ultimately trying to deliver. And I think this is why, we see Python being used a lot in the machine learning space, is because a lot of what's going on there is experimentation, right? It's trying things, trying completely different setups for your network, trying to like add in some stuff from like academic papers you just want to mock up real quick. And doing that in Rust would be pretty painful. Once you land on something like this is the thing we're going to ship to production, then I think it makes a lot of sense to now pay the price to do it properly and then make it a little bit harder to change down the line.
Do you think of where people sit on the spectrum or which tools they adopt or willingness to adopt tools, for example, as primarily, I just wonder about whether or not there are shifts in culture, from within industries or within generations of programmers. And, we're going through a process now where object orientation is kind of falling away from favor and functional programming is kind of very much becoming, let's say it's the wrong word, but mainstream after fighting for any oxygen at all for several decades. And I'm sort of struck by how human, or like how much scope there is for people to decide what they want, and the fact that essentially there's no rule book. There's just every team gets to set their own rule book. Is that right? Or does everyone get to choose their position on the spectrum?
I think everyone gets to choose. I think there are some choices that are perhaps more, I don't want to say rational, but fit for purpose than others, right? If you're working on, I don't know, making the next rocket to fly to Mars, versus you're trying to build like a website that can identify one cat from another for people's personal amusement use. Those are very different use cases, and the amount of time you should spend on analyzing and iterating on the exact correctness of your code is vastly different. The amount of resources you have available to do so are vastly different. And so it seems pretty rational to make different decisions. And I think what we've seen is more that there are more ways to trade those things off now. And I also think there's a recognition that some techniques don't really affect how correct your code turns out. I think there are some that we know do, like static typing being a good example, where we know that it comes at a cost because now more things have types, and that requires
literally more typing.
Yeah, there's literally more typing. But we also know that it reduces bugs. And so that is an example of a choice you have to make. Object orientation, and I think functional programming too, it's not clear to me that they fundamentally make a decision one way or the other here. That feels more like a matter of preference for how, like, do you like to read object-oriented code? Do you like to read imperative code? Do you like to read functional code? I don't think there's a fundamental, like, qualitative difference to what you end up producing. There's some once you start mixing in things like pure functions, right? Like pure functions, I think do have a point in the space. That said, you can write pure imperative code too, right? So that's not really a matter of functional versus imperative versus object-oriented.
Yeah, no, that's very fair. The reason I brought that up was just that I get the sense that there'll be people who try to kind of get their feet wet with some of these advanced, quote, advanced tools like property-based testing, for example, or fuzz testing or everything else. And it's like, well, there's just suddenly you start to realize how much you need to learn and you get overwhelmed and this kind of panic sets in. And for one of the other messages, I suppose, that you're sort of saying is that for a lot of software, you don't need everything. But when you do, it's good to know that the power tools are there. Like the tool is on the shelf, right? You can get it.
I think that's right. You know, I bristle when someone says I have to use these tools, or I have to do all this extra testing, or I have to do all this, you know, property testing. Like I have to learn about all these tools. I don't think it's a matter of have to. I think it's that you should be aware of what your levers are, right? Like which things can you make decisions about how deeply you want to go down with a given software project. And then you should trade off the cost of using a particular lever, so to speak, or using a particular tool or technique against the benefits it's going to give your particular project, the resources you have available for that project, and how much of an impact that has on what the users of that product cares about, right? So, producing, software bill of materials, like the full dependency graph and every version of everything is quite valuable for some set of projects. Like if you're delivering, I don't know, navigational systems for space shuttles, that seems like it's probably pretty important to supply. If you're delivering like an Android app that's a little game, probably not that important.
I can't believe you said that. You just no.
Right?
No. There has to be someone on the quote bad side. It's not actually what you're not actually saying that it's bad. You're just saying that the risk, like the risk profile is lower.
It's not even the risk profile. It's that it's not clear that there's any value to that, right? If you're going to spend time on something, that's not the thing to spend time on for the Android game, but it is the thing to spend time on for like the next NASA space shuttle. And I think that's what it comes down to is you need to be aware of what the tools you could use are. And then you need to have the sort of active thought process of which of these should I be using for this project? Which of these give a useful impact to the thing or things that matter for this delivery? And that is basically never all of them, right?
Right.
I think you'd be hard pressed to come up with a project where the answer was you need to use every single tool that exists in the entirety of the Rust and software development ecosystem to build this project correctly. Or not even build it correctly, to build it well enough for purpose.
I am like my brain is kind of running around in about 4 different directions, but let's try and stick to one, and that is related to the original idea of chatting to you. Was trying to like tease out as much as I could about how to build software reliably, or like how do we reliably build reliable software. And we've outlined a lot of sort of like essentially solutions to particular problems. And I wonder whether or not you had any thoughts around like what criteria do you have of like when specific things kind of tip one way or the other, like do you, for Like, do you have a checklist or some kind of like heuristics that you draw from?
It's a good question. And in some sense, I wish my answer was yes, and that I could just hand you a checklist. I think the reality is it doesn't quite work this way, and this is one of the relatively few times I'm going to say that you build this stuff up partially by experience. Like, this is one of the things where the more senior someone is in, not even necessarily in Rust, but in software development in a particular area, is the more likely they have to, the more likely they are to have built up a good internal sort of calibration for, is this worth it or not? I think the way to get up to speed on this quickly is to like ask the people at the organization who may have been there longer, or people who've built similar things before, sort of ask them about the things that they have found valuable and not valuable in the past. The reality is you're always going to end up using some tool that didn't actually end up mattering to you, right? You're going to have spent, days, weeks, months on building, I don't know,
some sort of some perfectly architected kind of test suite.
Yeah, or even like there are some really sophisticated testing tools out there. Like I'm thinking of Jepsen, for example, which is a famous tool for testing distributed systems. Maybe you have a system that's like a distributed system, and you spent a bunch of time getting it to work with Jepsen, and now it's like testing all of your things through this elaborate test suite, and it's never found a bug. Just because maybe your distributed systems protocol is actually simple enough that you didn't need that complexity to shake them out, or maybe the way in which Jepsen perturbs your system is not the place where bugs are generally in your system, and that then now that for the next time a little bit more about where Jepsen is appropriate, and a little bit more about what you're likely and not likely to get out of it. But some of this is from experience, but at the same time, you can also talk to people who have worked in or worked on similar things before and ask them, what have you found useful in the past? And conversely, what have you not found useful? And sort of build up your experience that way, not just from your own personal, like hands-on experience.
Could you imagine how frustrating it would be to bring Jepsen in? They're like a very famous consultancy, but presumably very expensive. And for them to be like, oh, actually, no, we couldn't find anything.
well, so Jepsen is interesting because the Jepsen
the closure thing you can run yourself.
Yeah, the testing infrastructure you can run yourself and integrate with, and I know because I've done it.
Okay,
and it is. I don't want to say it's non-trivial because it can be relatively straightforward. The thing that's really hard about it is you have to find a way to express whether your system did the right thing, and you have to express those properties in Clojure. And if you know Clojure really well, then maybe that's super easy. For me, it was hard not just because of the language, but also because I needed to find a sort of abstract way to explain the correctness properties of the system given these abstract descriptions of operations that got submitted. It's not very straightforward for any non-trivial property, but you can do it yourself. The question is just, is that where you should spend the next month of your software development time? And in some cases, the answer will be yes. I think, if we look back at the talk I gave at Rust Nation, which was called Towards Impeccable Rust, the title was chosen very intentionally, that your goal always, right, is to write a software system that is perfect, impeccable. There's nothing to say that is wrong with it. And you'll never get there, hence the towards, right? You just want to pick the best path towards that ideal. And there are a bunch of paths you can take there. Testing, like basically everything we've talked about today has been about testing. But there's also a bunch of other things you could do, like what are your processes for documenting your architecture, documenting changes, writing comments in your code, safety documentation? What are your processes for benchmarking, whether performance or outcome benchmarking? How do you do like enforcement of the correctness of your system using types? all of these things are additional dimensions you can explore. And I don't think we should explore them here, but it's more of the more you know about what paths are available to you, the better.
I have a question for you. I mean, hopefully, and it actually relates to the process of interacting with others on the team through primarily that we have ticketing systems. And there are people who are very effective at communicating through tickets and change and like code reviews. And there are some people who are marginal. And abrasive is too strong, but it's sort of like either non-specific or, there's just a whole bunch of ways to I think get human communication kind of horribly wrong. And human speech, I guess natural language, is relatively lossy. It's like is low bandwidth, and yet we use it a lot. And do you? I just because the documentation is important, everyone hears that, but not many people say what is also important is that you have high quality commit messages and you have high quality code review that includes like a lot of justification for what you're suggesting, because it actually becomes an archive. Now I've taken a long answer out of you, but I was wondering if you could either supplement, critique, or expand, or like shut down what I've just said.
Oof. So we could schedule another episode where I could probably talk for 4 hours about this topic. Like that's my rough estimate. If I did a stream talking about this, it would be about a 4-hour stream.
Have you done one like tandem? I feel like we could do this.
Yeah, probably.
We could do this as like a counseling session. I could come on to your YouTube and say, John, talk me through the process of writing effective commit messages.
Oh boy. Okay, so here's I'm gonna give a very distilled answer. At least I'm gonna attempt to do so. I think that the way that you maintain the quality of software over time is by ensuring that the starting point is high quality, and then that the incremental steps are high quality, right? Like proof by induction. And the base case is, how do you port software? And this is something we talked about in the early days. Like, how do I think you should port software to Rust? We talked about in the beginning of the episode. But then what you're getting at now is like the incremental step. How do you know that every change you make is high quality? And the way you do that is by having a bunch of automated solutions to check that every incremental thing still meets your quality bar. But it is also to have really good review of the changes that come in. And that includes a solid rationale for why that change is coming in, why it's the right time to do it, why it's the right way to do it. How you've sort of convinced yourself that it's the right one, but it's also individual arguments within the code for why is this part of the change okay? Why is this part of the change something we're okay to live with for the long term? And the only way you can get to that is with good human communication, both in the initial write-up, but also in the response to iterate on it and to make that code review better. The general rule of thumb that I have when I do code reviews is that when I approve a code review, it means that the submitter has done a good job and I agree with their rationale. I am willing to stand behind the thing they contributed as if it were my own. Now, that is a very high bar. Not everyone has the same bar, and it's not always the right bar either. But for the kinds of systems that I end up building at work, I think it is the right bar. But this is another place where you need to use like your own judgment for what is the appropriate bar for this stage of the product, for your collaborators, for the domain you're operating in, for your own point in your career, and for the contributor.
This is a very difficult thing for people who suddenly realize that they are seen as the senior developer on the team.
Yep.
Because suddenly they're the best. And one of the problems I say quote problems, but when you have people who have, let's say, a couple of years of experience, they make mistakes that you would not have. And part of coaching and kind of bringing them up is recognizing that you made those same mistakes yourself.
But sadly, I mean, sadly for the project and the project's velocity, they need to learn, and your job is not to identify the error. Or at least my sort of assertion is that your job as code reviewer is not to find problems. It's to get the best software that you can within the constraints, like, shipped. And that means helping people through the process of learning and growing. And just for other people that are sort of listening, Jon, I'm going to say, like, from personal experience, is like very, very good at politely declining changes to code and even documentation. And I will say this as a collaborator of
specifically Jon. Documentation, maybe even.
Yeah, actually, in fact, there might have been like one or two particular projects which I was like, I really feel like I should be writing more code. But no, like getting we had an internal product and it was like anyway. So actually, let's arc towards that slightly, and that the software that you are producing needs to be understood, or at least the context of it needs to be understood by a wider group than just your team of software developers. You're also communicating to management, you're communicating in some ways to customers either directly or via marketing. So marketing probably needs to understand what the product does and how it's going and how it's tracking. I feel like, is there a question at the end of the sentence? I think that there is, in the sense of, I'm very curious how to get that right.
Yeah, you're not alone. And I don't think I have any. I don't think I have any magical answers here. I think the best I can do you for without again a sort of 4-hour stream here is, we should, as engineers, spend a bunch of time not just convincing ourselves that what we do is the right thing for the project, for the code, but also we should understand that it is that is only half the job. And this is an error I see especially common in smart people, is the best way I can describe it, is this idea that, oh, if I have arrived at the right answer, then I'm done, right? Then okay, I did the thing.
Yeah, I've exhaustively searched, and I have actually, I've discovered the correct solution, and therefore, I would believe something different if I were wrong. Sorry, if something was. Yeah, okay, I get what you're saying.
Yeah, basically they've convinced themselves that I've arrived at the right solution, and they may very well have. You see this actually a lot in social deduction games too, where you have this one player who's just like, oh, I solved the game. I know who's evil, I know who's good, like, I figured it all out. But the challenge in both the technical context and in a board game context is there are a bunch of other people involved. And the reality is you will not get to what is right for the product or right for the end user until you can convince other people. You can get, not even convince, but get other people on board with the path that you have determined as the right one. And that does not mean convincing them, like talking them into your point of view. Sometimes they have context that you haven't thought of, which is why your like theoretically pure and optimal solution might not be the right thing for the product. So it is about having that conversation with the other people that are involved to both sort of help them see your point of reasoning, but also to observe the context that they may have that might affect your reasoning. It's a dialogue, it's a conversation. And that needs to happen to all of the stakeholders that's involved, whether that is your users, whether that is your teammates, whether that is your manager, whether that is marketing, whether that is like the CTO setting the direction for the technical aspect of the company. All of these should factor into the sort of right path forward. And that's not just to say that you have to check with these people on every single decision that you do, but it's more of it's not about the individual thing that you're looking at. It very rarely is. And this ties up neatly in an argument that the CTO at the company I work on now, he wrote a blog post a while ago on context-free code reviews, I think is what he's called them, where it's pretty common that people will review a code review and they'll just review the code that's in the code review. And I think that's a mistake, because very often the place where a code review goes wrong is not so much the actual code that's in there. It's, are we sure we want to make this change? Like, is this actually a good change overall? So a good example of this in the Rust space might be, oh, the code review like changes a bunch of these APIs to achieve a particular outcome. But what if we don't want to commit to having, this type be visible in our public API? What if we don't want to commit to taking this particular dependency because of, some supply chain concern, or we just don't want to add another dependency right now? And those things are not tied to the specifics of the code that was contributed. That might be just fine, but it's about the wider context of that change.
I thought that you were going to accept my change request to just, I want to re-implement serialization and deserialization just by myself for my custom data type.
Yep. Because it's correct, you see? Yeah. Sometimes it's the stuff that's not in the code review that you need to comment on.
Okay. It's like, dude, why are you spending 6 weeks to create a serializer?
Yep.
It's like, no, John, my custom file format
is optimal.
That's right. It's perfect. And this is just fascinating. However, I know that you're the kind of person who would say, look, I don't know everything. But so there's kind of two follow-on questions. And one is, how on earth does someone sort of kind of keep up? Like, do you find yourself just getting swallowed by the torrent of information? I mean, I can't read every blog post that comes out on This Week on Rust, for example. Yeah, that's the first question. Anyway, there's a follow-on, but hopefully we'll get to.
It's hard. I don't think I would say that I keep up. I think the way that I tend to think about this is that I usually discover things after the fact, right? I don't keep track of every new tool that's released. Instead, you sort of, I think this is sort of it depends on whether you're an early adopter or not. But I think these days, I'm not so much an early adopter anymore. It is more of I sort of let the dust settle and see what floats to the top, so to speak, right? So what I'll sometimes do is I'll go to the Rust subreddit and I will sort by popularity over the past year, and then look through the first few pages and look for things that are interesting. Sometimes I will look at, This Week in Rust, and I'll just sort of skim through for a couple of weeks, not read them as they come out, but just sort of skim through the top headlines and see, is there anything here that really stands out as, oh, I could have really used this. And sometimes it's driven by need. It's I recognize that, this is how I found Turmoil, for example, was, I had a system where I really wanted to, I had a bunch of these corner cases in execution, and I wanted to just mix things up. And so I looked around and then found Turmoil. It was not I don't think I saw the original Turmoil announcement. And that's fine too. So I think sometimes this is a mindset change of when you wish you had a particular tool, go look for whether that tool already exists, because it might.
And yet it's so fun to build stuff.
Oh yeah.
And
and sometimes that's how these tools manifest, right? Is that someone just built it for themselves and then turned out to be really good. So that's okay too. It's just, you should do the research first.
Yeah, I keep wanting to build a web framework. For example.
Oh, you as well?
Yeah, me too. I've actually name squatted a name on crates.io. It's sitting there waiting and gnawing at me. But I'm about a year late on all of my projects, so I can't prioritize that one.
Let me tell you, you only become more late over time.
I see. You're right. So I may as well just, yeah,
it's great. I have some projects I'm convinced I'm 5 years late for.
Oh, Jesus. The other question that I was going to ask related to if I wanted to build a tool, like what kinds of things would you like to see in order for it to kind of pass the quality bar for you? So presumably, let's say you've got some itch and you've looked around doing a little bit of cursory research and you come across some new thing. I don't know what hasn't been written yet, but presumably there'll be something which hasn't been written. And where would you look to check whether or not the signs are right that this is a quality thing?
So for tools, I think it's actually really simple. Does it solve my problem?
Okay. Yeah, sure.
Right? Because tools are easy. Adding tools to your dependency chain, it's not really that much of a problem. Usually you can run them in a sandboxed environment. They have read-only access to your code. They don't get to talk to the network. You just run them and they do a thing and give you sort of a yes or no output. So there's not a huge sort of supply chain security risk there, at least assuming you can run the tool well. And what matters is, does it either find the kinds of problems I'm looking for, or give me the insight that I'm looking for, or produce the result that I'm looking for? And then it's how reliable is it? So if I run this tool, 10 different times, does it solve my problem every time? Does it solve my problem, 5 out of 10 times? Or does it solve my problem 1 out of 10 times? That is really the only metric that matters to me. If it solves my problem 1 out of 10 times I use it, probably not a tool I would keep using unless I think I can fix that and make it 5 out of 10. If it's 5 out of 10, that seems pretty useful. If it's 10 out of 10, this is an amazing tool. Very few tools are that versatile and robust and sort of resilient to variability in the use. I think for libraries, there's a much higher bar because they would be a part of your code. They would essentially be a part of the quality of my software. Whereas for tools, I think the bar is just, does it do what I need it to do?
Do you subscribe to the notion that you should be prepared to adopt a library, if essentially take over ownership if the maintenance, like the maintainer were to kind of like decide to wave it goodbye? Do you feel like if you take a dependency, you need to be prepared to essentially deal with the worst case?
I think that's too simplistic of a view, because imagine that you're a 1 or 2 person company, you're building a little tool of some kind. It's used for like real things, like you have a bunch of customers, but you're a small team, and you take a dependency on, Surdy, you take a dependency on Tokyo, you take a dependency on, one extreme case like Rust on the standard library, you take a dependency on, the image crate for generating whatever images, you take a dependency on the Axum crate in order to do web stuff, you take a dependency on the tracing crate for logging.
We're creating our cat identification superstar app, right?
And you take a dependency on TensorFlow because you need that for your machine learning thing, right? Mm-hmm. It is not feasible to say you need to be on the hook for, if any of these projects go under, you have to take them over. Just not feasible, right? If you're a giant tech company, then maybe, but even then it's not clear that you can sort of resuscitate and keep a project alive on your own. So I think this is more of a collective action kind of problem, where as a community, if we all find that we're taking dependencies on sort of critical things, I think curl is a good example of this in like the world of the internet, where it is a critical dependency for a lot of projects. And we need to think carefully about how can we as a community ensure that it has continuity. Some of that is supporting the current maintainer. Some of that is trying to see if we can help grow and improve the maintenance of that project, such as, there's been books written about this literally. In fact, I have a book. Let me find it real. Nadia Eggball. Nadia Eggball wrote a fantastic book on this called Working in Public: The Making and Maintenance of Open Source Software. I think it's brilliant, which talks a lot about like, how do we help maintainers of open source software continue to maintain that software? And the answer isn't send them lots of PRs. That doesn't work. Sending them money, maybe, but it's unclear both how you do that, how that scales, and how that ultimately impacts the long-term viability of the project. Because while you continue to rely on one person, you have the bus factor problem. And ultimately, I think this is something we haven't solved as a tech community of how do we ensure the viability and dependability of the dependencies that we take. I don't have a solution for it. I do think that the answer comes down in part to when you choose your dependencies, choose them with care, right? Think about whether this is something that is likely to become unmaintained, and think about how costly will it be to change if we need to. There are some dependencies where like a bunch of alternatives exist and you picked one that you like the most, but then, in 10 years, who knows, maybe that project is dead. If there are a bunch of other alternatives at the time, chances are you could probably switch to something else down the line. And it's not that bad because they're all kind of similar. Whereas if there's only one dependency that provides this particular thing, then changing down the line might be extremely painful because there might be no alternative. And if there's suddenly, if the main thing in that space goes away, I mean, we saw this sort of with Serde YAML as an example, where the question is, what do we do as a community? And the answer is, it's not going to be, each company forks the crate and then maintains it themselves, although that is partially what happened. I think the reality is, as a community, it needs to be taken over by someone or a set of people who can own it longer term.
Yeah, I think that actually I just written YAML down, and so well done for telekinesis or something. But the case of YAML is interesting for Serde YAML. So if people aren't aware, which presumably there might be one or two people who are not, essentially the crate wasn't being well maintained, and the maintainer thought, you know what, I best just yank it essentially, or essentially make it not available for public consumption. And
it's still available.
Oh, right.
Out there. It's not yanked. It's just deprecated.
Okay. Right. So deprecated. Right. Yanked in the metaphorical rather than the crates.
Yeah. The GitHub repository has been archived, so it's read only. And the latest version that's on crates.io has a sort of deprecated tag on it, but it is still consumable. It just is publicly stated that it will get no further updates.
And therefore, a lot of people were like, whoa, what do we do? Okay, I better write a YAML implementation for Serde. And for about 3 or 4 weeks, there was just kind of this mushrooming effect, or at least there was a vacuum, and there were lots of people who kind of tried to fill the vacuum. And I think that's very likely to happen in any of these major cases where there'll be some
I think it's what we want to happen, right? If something does end up ceasing to exist in some way, then something's got to fill the vacuum. Many things will try, and then 1 or 2 or 3 are going to emerge as the new preferred candidates. But I think there's a step before that, which is how do we try to preempt that from happening in the first place, right? How can we spot this ahead of time and make sure that someone else is or a set of people are owning this thing rather than one person?
And what I would suggest, although I'm very curious as to whether or not you agree, is actually actively participating in the projects sometimes can actually be very motivating for people. Knowing that there can be,
it's just
users.
Hard. It's just very hard. Like if you, even if you're like a small sized business, chances are you have hundreds of dependencies, maybe even thousands if you start counting things at the operating system level. Right, and at that point, you just can't contribute to all of them. I do think that there is a lot of value in expending resources on contributing things back upstream. If you have changes locally to a dependency that you need to have in order for your product to work, try to contribute those back. Sometimes that's not feasible. Sometimes those are effectively hacks that are never going to be upstreamed. But think about, can you develop this in a way where it's not a hack and then contribute that thing upstream? It will take more work, but maybe it's worthwhile.
It'd be nice to not maintain those patches.
Right. And sometimes it's looking at your dependency graph and looking at, okay, we can't help out with all of these, but maybe there's like one or two that are, it doesn't look like a lot of other people depend on. There's like only one maintainer or something. So you can like try to focus your efforts a little bit and say, this one in particular, we're going to take an extra interest in. But even then it's really tough because it doesn't really align with business incentives, right? Like that's it, especially if you have a small team, you can't really afford to say to one person, you're going to spend, 80% of your time working on open source things now, unless that is very critical to the business. And that I think is in practice pretty rare. So
yeah, I mean, even 2 or 3 hours a week feels like, well, that should be 2 or 3 hours a week that you should be, on the job.
Right. And so this is where I think we get more into the, how can we use money to help with this problem? Like how can businesses use money to help? And I do think things like, sponsoring the Rust Foundation, the Rust Foundation is one means to an end here. I'm not going to claim that they are the perfect one or that they cover all cases, but it is a start, right? It is one way to try to effectively pool money and then try to disseminate it to the highest impact areas. And there are other ways to do so too, right? You could do GitHub sponsorship to individuals or open collectives. But ultimately, like, money doesn't fully solve this problem. And this is one of the things that the Working in Public book, I think, does really well, is that sometimes, like, what's needed is humans to go help with often not even code. It's like triage or reviewing code reviews, where
writing documentation is actually,
or writing documentation, yeah, or like improving the sort of standard of the code, improving the CI, a bunch of stuff that like is maintainer work that is not even necessarily about the code. And I think figuring out how we incentivize that kind of work, especially given that the consumers are so disparate, they're so split, right? Like if you look at a project like CertiYAML, right? It's not like it has one or two giant customers who we could easily trust to just sort of take it over. It's that they have, probably thousands of companies, if not tens of thousands of companies, all using it for probably things that are important to their business, but not like a business outcome. And if each one of them contributed, 1 hour a week or 1 hour a month, then that would be plenty to keep the project going. But it's not clear how you pool time. It is clear how you pool money, right? And so there's sort of a lever of indirection or something missing here, or some mechanism missing here that I don't have the answer to. But I don't think it's fair to say that for users of Rust, like companies using Rust, that they should be on the hook for all the dependencies they take. I do think you need to be discerning about what you choose in the first place, and you should think about how you can help this underlying problem. But I don't think it's you need to be prepared to step in to take all of them over, because then you would take no dependencies. And that's worse.
It is significantly worse for everybody, actually. It was interesting that you mentioned, okay, so for a small company, things are slightly different from a large company, but in the large company case, it is different. And one of the other things that I noticed is that the promo process becomes very complicated if you're contributing to open source, because this is very, very difficult to quantify, and B, difficult to demonstrate. It actually kind of ties back to metrics that your promotion is probably tied to.
Yep. Yeah, and I think part of this is also just the farther you are removed from the business impact, the harder it is to argue for promotions, for even, or not even for promotions, but for like performance reviews, right? And I mean, we felt this in Builder Tools at Amazon, where our customers were other internal developers. So we were already one step removed from the business impact. And so even there, even though that was work that was happening internally, even if that wasn't necessarily open source work, even there articulating for the impact of your changes and the impact of your work is difficult, because you need to argue about sort of force multiplication. And you need to say, we enabled them to work better and that produced this value. And with open source, you're even one step further removed, which is I worked on a thing that other people, including us, use, and that allowed our developers to not be slowed down by the dependency they took, or worse yet, reduced our risk, which is very hard to quantify, which in turn resulted in a business impact or the lack of a negative business impact, and that's just really hard to articulate. And I don't think that there are many companies that have figured out how to take that kind of work into consideration for things like compensation or for review. I think it's worth spending some time thinking about as a company and as an individual, like how can we measure the impact of working on open source? How should a company value 1 hour spent on open source maintenance? I don't think there's a great answer to it, but without that, we're just sort of in the blind. And if there's one thing we know, it's that companies hate putting money towards something where there's no clear output from that money.
Oh, look, as someone who's trying to organize a conference for next year, it is surprising. It's like, turns out reality is harder than my idealized dream. Yeah, no, and that's fair. I mean, I can say things like it's great that we have a conference for the whole of the Asia Pacific region that, at least from Australia and New Zealand, doesn't currently exist, etc. And no one sponsors a conference out. Very few people sponsor a conference just out of altruism. Businesses are not altruistic enterprises. They require a return either via marketing or via recruiting. And particularly not many people are recruiting at the moment. I don't know if you've heard, but the economy, like, no one seems particularly confident. At least that's the vibe that I get at the moment.
Yeah. And I think, if I were to turn this around on you, right? So organizing a conference is also a business development thing on your part, right?
100%.
So imagine that someone now came to you and said, "Oh, actually, Tim, while you're doing this conference and everything, that's great, but I would actually like you to pay a person to spend about like a couple of days a month on doing some open source stuff that underpins the platform you're using to take signups. Would that be okay? It's going to cost you this much more money per month."
Yeah.
Right? Like, how do you convince yourself that that is worthwhile? The answer is probably, I'm not going to pay, $100 or $1,000 more a month for something that has no intrinsic value to the thing I'm trying to deliver. And it's the exact same argument.
Yeah, and I think I have, as a business owner now, I have a lot of respect for, I don't want people to come as like some sort of charity case. And I don't think that you should treat yourself as a charity if you are writing software for customers. It is transactional, the whole process. Like that, this is capitalism. There are lots of people that advocate very strongly for it. There are a lot of people who are friends of mine who advocate very strongly against it. But that is a system, like it or hate it. This is the system that we have, and this is how we are. This is how we're operating, and we haven't figured this out as an industry. The fact that we have such a heavy reliance on goodwill from individuals and smaller businesses that much larger companies essentially freeload from legally. And yet this kind of essentially is like we are planting a minefield for when that maintainer decides.
The reason why they do is because it is, in some sense, because smaller businesses haven't figured out how to collectively do the thing the big businesses can do pretty easily, which is help with things like maintenance. Because again, pooling time is very hard. But that is, I think, what you end up having to do if you want the maintainers, or if you want the maintenance of some of these critical dependencies to not be reliant on big companies. That means they need to be reliant on pools of resources from small companies, and figuring out how to pool resources is very hard.
I like your idea of thinking locally. That is, go and take a look at your dependency graph and say, well, this is an important thing that isn't super important for many other people, and so we're going to take a special interest on that, and maybe develop a personal relationship with the people that are building it. That strikes me as a practical way where, you could kind of divide and conquer. The industry could actually divide and support each. It's not a perfectly it won't be a perfect division. There'll be places where there'll be oversubscription, undersubscription, like there are Powerbulls and there are other dynamics at play as well. But that seems like somewhere to move towards. Yeah, it's a start. I feel like I really want to think of some way to end this positively, because we've been chatting for a long time and we've had this lovely
here's the positive
through the forest of software.
I'll give you a positive
to the glade, or the kind of the meadow we've encountered with like a bubbling brook, like a nice little pretty stream, and there are butterflies and flowers, and this is where we're having a picnic or something.
Okay, I'll give you a positive sort of take-home note here, which is that at least when it comes to the quality of software, how do you build, the sort of theme of the episode, right, at the onset was, how do you reliably build reliable software? And I think the positive note here is, it is not a black and white thing where either you are reliably building reliable software or you are not. The way it actually works is that the more effort you put in, the more reliably your software will be reliable. The question is just about, where do you put those investments in to make it more reliably reliable, faster, sooner, or with less cost. And so you can't really go wrong, right? You can take steps where the cost was greater than the benefit, and now you've learned something for the next time. Sometimes you will take a step and it didn't really impact how reliably you build reliable software. And sometimes you'll make a huge improvement. But the reality is, you're always kind of moving forward. It's just about the speed at which you're improving your process. So ultimately, don't fret too much about this. Don't spend ages trying to figure out but which path should I take when it comes to X, Y, and Z? Instead, just focus on delivering value to your users. And then as you go, think about what is a high impact, relatively low cost, or relatively here being an operative term, right? Like something I'm willing to spend in terms of resources, but I get a high impact for something that I'm willing to invest in, and it makes a meaningful difference to the security or the correctness or the reliability of the software that I deliver. And then you keep moving forward, even if it is a little bit of a meandering path. But you can't really go wrong here, because all of the things improve your posture.
Thank you so much, Jon. With that, I would like to kind of call the discussion to an end and just say thank you to you and everyone who's listened all the way through the episode. It's been a real pleasure to learn and share and grow. Thank you very much. This episode will be at the URL timclicks.dev/reliable-software, and there will be a transcript, show notes, and links, so that if you have any further follow-up questions for myself or Jon, we'll find a way to get them to either of us. So thank you so much, Jon, once again, and I really wish you a very pleasant week and all the best.
It's been a pleasure, Tim.
Ta-da!
We did it!
Yay!